Woohoo!
Hello.
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 Trying to avoid making noise in the very beginning so I don't end up being the thumbnail.
Okay.
I remember there's like a predefined, isn't there like a predefined length of time at which it takes a
Oh, I don't know. I've
thumbnail?
got no idea. Like, no idea.
People used to take advantage of that in YouTube and put like a single frame at exactly the right point so they could control the. You could even, if you make it a single frame, you usually can't see it when you watch the video, but you can, so therefore you can make the thumbnail completely different to the content and things like that. I don't know if it probably doesn't do that anymore. Anyway.
Okay. Crap. So yeah, long time no see here in public, recorded.
2 weeks.
That's forever. So a couple of things we wanted to discuss. We discussed about that, not on the mailing list, but we did discuss about that. And those things are namely, well, we want to discuss the possible Ehcache cleanup work. Well, not cleanup, but what we want to do with regards to all the logic with the loaders, injection of a bunch of other stuff. So we may want to discuss that. And then I thought that maybe I would want to discuss. Oh, I threw away the diagram that I used to draw to explain my ideas to Ablash earlier today about how to tackle the right behind, but I probably can redo it or something. So if you have time for that, it's something that you may want to discuss too. There may have been other things, but I've forgotten about them. So if someone has anything else, let's get started with the fun stuff then. So suppose the cache is to be fast.
Yes. And one thing we discussed multiple times, and you hinted at on an email to the mailing list last week, I believe, was that we do a whole lot of stuff in the get path, for example, which clearly should be one of the points where optimization would make sense. You know,
minor detail.
Yeah. So in that context, what I did was look at the code, and as discussed, when you drop everything that relates to cache loader writer, so you suddenly say, I don't handle cache through anymore, the get code becomes way simpler. Let me try one thing. Into presentation mode. Yeah, that works. That's awesome. Let me share then. That's going to be the easiest.
And you need to click present to everyone.
No, I can't. You have to do that for me.
Oh, do I?
Because you're the boss. Yes.
I thought you were the manager. What's going on here?
Oh, don't start there.
You're presenting to everyone.
Thank you. So on the left-hand side, you've got the get code that actually doesn't fit on the page. Well, actually, just fits. I think that's the proper closing. Yeah, it just fits on the page. And on the right-hand side, you've got the cleaned up get code, which happens to be way smaller because, of course, on the get path, you actually get rid of the full function. So the function is completely dropped. And you replace the store compute if absent by a straight store.get. But then, of course, just changing that is not enough. You know, you've got to figure out if it's faster or not. So what I did was go into, where is that? Too bad I can't switch between two projects while in presentation mode. Oh, come on. Okay, I understand what you're saying, Alex. It's sluggish.
Sluggish, right? Yeah, it's
I have no idea why, but it's sluggish.
I got ideas.
So
Yes.
yeah, I don't want to figure out the details, is what I meant. So what I did was look into GMH, that that benchmark framework that does micro benchmarks and others. And I set up a benchmark which we can already discuss to see if it's valuable. So the benchmark I'm doing is getting a cache, get an entry, return that. So this is the infrastructure provided by the framework to make sure that the JIT believes I'm doing something with the value and just does not like drop my code completely because it notices no one uses the result. For the moment, I still have the version I showed Alex yesterday, so I'm actually hitting 15,000 keys while I fill the cache with only 10,000. So one hit out of 3 is going to be a miss, which actually escapes then all the expiry tests and whatever. And yeah, other than that, it's a standalone cache builder. So it's a simple cache, not any option, meaning that it has no expiry, no maximum size or whatever. And I'm using the thread scoped state for the random so that I'm not actually having contention on creating random values. And so that's a simple setup. And when I run that, the results is actually simple to double. So the numbers I have, is it gonna show? Yeah, it's gonna show. That should go away.
You have to make that bit bigger. If you want me to read
Little
it.
tiny bit.
As in about 5 times bigger.
Yeah,
Sure.
not bad.
That better?
Yeah, why don't you just make it go full screen?
It's not gonna increase the font size.
Yeah, but if you make it go full screen, then you can increase the font size without having to continually resize the window.
That's true.
That, and it will stop having the.
It'll also stop wasting bandwidth on the. Oh no, it's a semi-translucent background.
Yeah, I hoped it would go away. Anyways.
Yeah, no, sorry. Wait.
Plus, it's
That's
white on
wonderful.
black, which is just wrong.
Yeah, I know. There you go. That will do the trick. So the way I run it is by using the default from GMH and just having 4 threads hitting the benchmark in parallel. And so the way GMH works is it does 20 warm-up iteration of a second followed by 20 measurement iteration of again a second. And so these are the results for the fast version, which gives here. So that's the.
What are the?
Yeah, that's the number of operations. It's weird because it says error at the top of the column, but I believe error is the question mark. So, so that's the throughput.
What's the throughput? Isn't the score 17543882 for the observations per second? I'm trying to marry that up. Oh no, maybe not.
I thought that would be
the question mark. I suspect the question mark is a plus or minus that's not rendering in your shell.
Let me check that.
And so therefore it's 17543882.663 plus or minus, in brackets, 99.9%.
Yeah.
So the 99.9 percentile is plus or minus that.
Oh yeah, you're correct. Then I completely misread these results.
Yeah, we got the results. So okay, so because I cannot.
Don't know if it's assumed symmetric errors or what, but
Sorry.
It's hard.
all right. I'm intrigued to know why your shell doesn't render the plus or minus. It should.
Ah.
You have a weird font setup for your shell.
Yeah, possibly. Although it's the font I use in the IDE, so it should render
It
that.
might also be that the might be the character encoding that the shell's using, or it might be doing like a VT100 emulation or something, and so it's anyway.
So that's the previous one.
What am I supposed to look at? Sorry.
So you've gone from 1 to
So
12 million to 17 million.
Yes, exactly. And the percentile is the variance is higher in the other one. So that's
Probably
the
by
one with
how much higher?
twice.
It's not a huge amount higher when you consider it's gone from 12 to 17. It's almost, well, it's not gone up by twice, but
All right, so it's 50% then, right?
So where does it get the statistics from? How does it no, this is not a question for now, I know. Sorry, I don't know JMH,
so I'm again not a specialist either. But so it's getting the results from so the framework measures that.
The number of times it can execute it, or
I've left the default configuration, so it's actually trying both the throughput, extracting a mean of the time it takes, that kind of stuff.
Okay.
Does it do that like by doing individual paths, or does it try to compose, to extract multiple information from a single run? Again, I did not go into the details yet. But so that's something, for example, which could be improved. I could go look deeper into the benchmark and look at what I need to. What do I need there? Oh, come on. Oh no, that's not the one that has annotation. Sorry. And ask for more specific outputs.
Okay. That's fine.
But I was first initially wondering. So one thing I could do is I could change that one to be way more simple and just be and do something like that. Oh, sorry.
Right, so that's trying to scan through the entire
Needs to be
population in how do you say, in circles.
Oh. Yeah.
Yeah.
And have even less time be taken by the. I would need to rename it, but yeah. So most of the time would be really in there, because that's probably a cheaper operation than getting a random number. So we're reducing the impact of.
And you're also purely measuring like. Wow. Yeah.
The other question is, I could actually get with a constant, but would the cheat be smart enough to realize that since I'm getting with a constant, the result can't change, meaning that my cache.get actually has no side effect, and so
your JIT will do weird things inside the map because you're always following exactly the same code paths.
Yeah.
Well, it might do weird things inside the map because it's always following the same code path. I would suggest that what you've got there is as simple as you'd want to go. I wouldn't want to do anything more synthetic than that. And
Yeah.
even that's maybe a little too synthetic.
Yeah. Okay.
But it's probably defensible if you want to get a pure read on gets or hits or misses or whatever. You're skewed because of the modulo, not a power of 10, but
Yeah, but
only
yeah,
slightly. Actually, really, really slightly. Why?
Okay, so we could.
So
Yeah, go ahead.
the question now is, the result shows a difference. Should we test other methods? Meaning, should I look at the put path, etc.? Although the simplification on these paths are much less critical. So, just to give you an idea, if I switch back to the
So you gained from 12 to 17 million by doing what you just did.
oh, come on.
Yeah, I that's not the way the results were read the prior run. So now, effectively, we're looking at a single run thing. So I understand it makes multiple iterations and blah blah blah. So it should be about good if it then means all that out. Yeah, so maybe that's good enough. So yeah. Anyways.
Okay. IntelliJ wins, I lose.
What do you mean?
I'm trying to move back to the Ehcache 3 project, but each time I switch my windows and then go back to presentation mode, it switched back to the other project. I'm like, okay.
Software.
Yeah, so sorry. But so yeah, so what I was
because how do we feel about it? So let's say we trust all those results and they're perfect and blah blah blah. What's our stance now? It's a non-neglectable difference, right?
Yeah, but we knew for a long time we'd need to make that. But here's my thing, right?
I know. But so we need to make what? That's what I'm getting at. So what are our options?
I think it is number one priority to make it such that when you are not using writers and you're using, and let's be clear, the common case, that it follows that code path and you get that 17 million or whatever it ends up being when we've done all the rest of the work that needs to be done to it.
Okay. So.
And then the secondary question is, what's the cleanest way you can get to that point? And to me, that is a secondary question. And I can think of a bunch of ways you can either bifurcate the classes completely and have separate implementations for when you're using writers and not. You can try and push the writers into a layer beneath and have a layer between the cache and the store where the writers are invoked.
Okay,
those are the two obvious things that jump out to me. Because when I looked at the two implementations,
slightly bifurcate it. I would introduce the. I think I would introduce the
layer.
No, a subclass, and just have the proper thing plug in where it needs be, where we think it's relevant. Worst case, because
Oh, you mean have empty abstract methods that you can?
Yeah,
empty methods you can override.
Because so if I remember right from the code I just saw, there is the get that then updates the stats, and that code should be about common. So I think there's something that we can, just factor out. And then the get is something you want to pay a whole lot of attention to, probably the put too. And then all of a sudden you can start making trade-offs.
So, for example, in the context of a put, given some of the stuff we have with the 107 integration, and the new value already expired behavior, we don't get rid of the functions. We still do need to call compute, and we still have stuff happening in there, also because of the event notification. So get is really the only path where you actually manage to drop the function completely.
Yeah, but it's the most important path. If you consider
no,
that most caching use cases, you need to be hitting.
Yes, and so in that context, one other thing that Alex and I discussed at one point is it because the code is longer, or is it because we need to instantiate these functions and wrap them in the memoize each time?
No, my take it's that, right? It's the additional allocation.
What
the
happens?
complexity of the code path isn't much more complex per se, especially when the JIT looks at it, I'm pretty sure. So in this test at least.
What if, and should I proceed with that, what if we do something like having a thread local for the function so that we don't have to worry about multi-threading, and we just memorize it on the thread, forget about and clean it up properly, and then you can actually have a per thread once in a lifetime allocation of the function.
The memorizing is only relevant because so it's only stateful because of the exceptions, right?
Yes.
In case of failure paths, so you don't even need to do any
More
of that
importantly,
stuff.
writers and exceptions.
Right. So right now, what you could do is just more important, but very true, Chris. So right now, actually, you could just exactly. Can we do this?
Do what?
Try to source the function from a different place. Have you tried that? So that it's
no, I've not tried it, but it's an idea. Yes.
Because right now, what you could do is simply do new and stick it in a static and reuse that, right, and test that.
Well, here's the thing for me. What I would love to know is, there's two roles that these kind of tests can play. One is that they should probably be running all the time to try and test regressions. Or rather, there should be performance tests being run all the time to try and catch regressions if we introduce them. But I'm more interested to know not that this is 17 and the other one's 12, but what aspects of what you removed gain you what? What got you to 17? Was it all in one specific piece of removal? Was it all like we're all saying, oh well, let's source the function from somewhere else and let's see if we can eliminate it and do a user thread local or not memorize?
No. I'm saying now having a bypassing the instantiation is really easy. It can be done in 3 minutes.
Yeah.
And run the test and see where it gets you.
Yeah,
I'm sort of arguing for what you're arguing for, I think, Chris, is try to figure out where all that time is spent.
Yes.
And honestly, I don't think that profiling this will tell us.
Well,
I mean, it's
not
so
in
easy
the
to try the other thing.
in the Java bytecode instrumentation thing. I mean, take the original, run it through some performance tests, do some timing on it, then tweak it, do the same thing, tweak it, do it manually. Figure out
That's
not by don't do it by bytecode instrumentation because we may not trust it. Do it the pure crush under the weight of runs way, and figure out what single thing costs us. Because until that point, we can't really make judgment calls on what the best way is. We know that we want to get to the 17 million, but until we...
Oh, that's a good one. We stripped everything. We know the difference. Reintroduce every bit at a time.
Yeah.
And
well, actually, I would start from the complex stuff and
start reintroducing the things that you think are expensive intuitively and see if you're right.
Mm-hmm. Yeah, so I would go initially, since I'm testing with no loader writer, I would go with a static, so a single instance of the function and see what it gives.
Okay.
And drop the memoize part of it because I know I'm not calling it twice. So, well, actually, no, I drop the memoize and make it static. Job's done, and see what that gives. Okay.
And then wrap that in the memoize.
Sorry?
Still static, and then wrap it in. Oh no, you can't.
No, I don't want to memorize it. Wow.
Yes, you can, but you need to clear it every time.
Yeah. So, which I don't care for the moment. So.
Yeah. But it's additional stuff. Anyways, it's cool. So that's the plan. Trying to identify. That's what we discussed yesterday. Effectively, try to figure out what costs what.
Yep.
And then from there, we can then decide how we can do
and what kind of complexity we want to put in there. But actually, part of my ideas in the Ehcache cleanup task is actually to find a way to pull out these functions and have them sourced from a different location. Because if we manage to do that, and I'm no longer speaking about performance, I'm speaking about testability.
Mhm.
If we manage to do that, then it means we manage to pull out most of the loader writer related
Right.
code. And then suddenly you don't have to test the matrices anymore. You just have to test loader writer stuff and cache stuff.
Yep. I like that.
Yeah.
Cool. That being said, okay, let's not discuss this here. So let me ask this question one specific way. Do you keep on working on this, Louis? Do you delegate this to somebody else? And when you answer that question, what I care about is when do we want to have that one answered, i.e. how we go, like what are the problems, how we could go about it, and then actually go about them.
Good question.
Well, then ponder it.
Well, I'll ponder that.
But yeah,
Yep.
it's cool. Is that it then for that?
But I think it's it then. Yep. That's
fine. Cool.
If I don't know, Aurélien, if you have GMH experience, so if anyone has or read stuff that points to improvements and things, because initially, for example, I launched it saying, "Oh yeah, I want 100,000 iteration as my warm-up phase, and then 100,000 iteration as my measurement phase," to realize that he was actually talking about 1 second long pounding the method stuff, which when you use 100,000, I've stopped it pretty fast because I was not that patient. And so, for example, I also said fork it 4 times, but that's actually just means it's going to fork the VM 4 times to average measurement, which is not the same as 4 threads. That means you've got parallelism. Because I could also test that with a single thread. And then it's...
We don't care. You can,
Yeah.
for interest's sake. I even think at 4, I'm not sure how many cores you have, but yeah, and anyways, there is more. But
I said 4
you want to put some pressure, like, given what we're talking about, I don't care that it's fast with a single thread. If it is, it's cool, but it's irrelevant. It doesn't solve any problems.
I said 4 because I guess I was running it on my machine.
And that's something we can...
I probably
maybe test on bigger machines at some point. So
yeah,
because
check we've got the same.
Right, because if all of a sudden the gap like diminishes a lot because of other contentions, you know, it may get lost in all that. Then, at this stage, I think we should we can and we should try to make it better. So it's and as you said yesterday, it's an interesting exercise to go through just to.
Yeah, sure.
And actually, you shouldn't run it on your machine. Because you're not going to.
No, I know, and I'm logged in. I've got my mail, I've got my browser. So again, I've spent a few hours on that. That's an initial stuff. I'll probably prep. So the good news is that so GMH, you like create a Maven project by using an archetype, and when you actually build the benchmark jar, it's fully shaded in, so it shades all the dependencies it needs, and so you can just move the jar elsewhere and run it. And it's a simple command line. It has no dependencies. It just runs like that.
That's cool.
So it's pretty easy for me to make 2 benchmark jars, one that has the full Ehcache, one that has the non-full Ehcache, and just run them on a machine.
It would be nice to do this probably rather sooner than later, if it's that easy, especially, right? I mean, just run a machine somewhere, an 80-core machine, and just run that. Well, stupid question. We're sure we gave like enough memory for that VM to do that test, right? We're not measuring any other. There is little churn, anyways, right?
I've got what? I've got
It's got
10,000
10,000 keys.
Yeah.
And my
Yeah.
and my value is a string which says some value and then the key concatenated to that.
I just meant there's more churn in the current like thing. Well, the whatever we have, I wanted to call it trunk, but it's not trunk. So on the production line, whatever you want to call it, on master, not the tweak thing. So, anyways, I just thought out loud. Sorry, just wanted to make sure.
I can give more memory to the VM and see if it.
Just run the GC logs and make sure that it's all good.
Yeah.
No need to. Just thinking out loud. Sorry.
No, it's true.
Sometimes stupid mistake. Cool. So yeah, and then I would try on the.
Yes. On a beefier machine than my laptop.
On a beefier machine, I wonder like if I wouldn't go for more values than 2, right? Than 10K. Whatever. Just run the same thing, and we'll see. Based on the results we made.
Oh, I can put 100. Or a million.
Just run exactly what you have, and let's stick with that for the moment.
Mm-hmm.
Let's be honest. Like the use case we're talking about here, like the heap stuff, and the don't run it on your machine. I sort of almost yes and no agree with that. Because yes, obviously I care about the 80-way system more than the 4 or the 8-way system that's on your thing running Mac OS 10 versus running Linux and blah blah blah. But sadly enough, a bunch of people when they actually do run some quick comparison stuff, they will run it on their laptop too. So I'm willing to know what's going on there as well. Cool. All right, so that's a good start. So you guys want to discuss right behind a bit quickly?
Sure.
Sure, why not?
Chris, some of that I think will be like yesterday's news to you, but so the quick intro. So the problem with the right behind as we have it today in the Ehcache is that it requires careful tuning. So because when you put something in your cache, to take that easy example, there are 2 storage operations that happen effectively. One is we put the key and the value inside the store, and we enqueue a action or something of some kind that says update this mapping, the mapping of this key to this new value, right? So the right thing, effectively. That will be delegated to the cache writer, and the cache writer says, oh, okay, it's an update, so I'll write whatever it means to write KV to my system of record or whatever I write. Now the problem is that if you say you configure a huge write behind queue in a very small cache and you pounded it a lot, you're going to evict things or expire things, too, maybe, from your store so that things are still sitting in the right behind queue, and you would then, if you use this as a loader, you go through directly a system of record and you hit the old value and not the one that, and we repopulate your cache with the old value. Right? Problem makes sense? Awesome. So we said it would be cool to cope with that. So that's the way. That's one of the reasons why also the unification of the cache loader and cache writer seemed to make sense. And so what I proposed that we do for now, I'm going to go into implementation details quickly too, is that if you configure your cache to be right behind, that we rob the cache loader writer instance that was provided by you in one of our own that knows about your cache loader writer, but also knows about the right behind queue. So then now, if a get happens, there is a miss, it falls back to your loader, but not directly. It falls back to our loader that first goes query the right behind queue, sees if whatever needs to happen. It works for updates, deletes, and whatnot. It's slightly different code paths, but effectively can retrieve the action, the latest action enqueued for that key from the right behind queue, and based on that, decide to return a value as if it got loaded from the system of record, even though we never called into your loader. Does that make sense?
Yes, except you use the words loader and writer like they're separate things.
Yeah, I'm in the methods in this case, so they're really separate things.
Right.
No, they're the same thing. It's just that, yeah.
Yeah,
So,
I just want to make clear there's one object here and one set of state. The two is in one place. It's not like there's no breaking of encapsulation or any sort of OO principle breaking here.
Nope.
It's one object is inspecting its own state.
Yeah, so, exactly. So you, yeah, totally. So the way that I told Avalanche to just implement this for now, I don't care, brute force, like walk the entire queue and just find the latest thing and return that. We're talking on heap, we're talking sitting in front of a RDBMS that goes over JDBC, blah, blah, blah. It's not going to be huge. It's fine. It's probably not going to be good enough forever, and certainly not for other implementations than the stuff that's on heap. But at least that all then...
Get it in place and working.
Sorry?
Get it in place and working.
Yeah, so we can get it in place and working. We can then also, and then we can port, like improve that on heap implementation and come up with different ones for other things, like if provide like persistent queue mechanisms and so forth.
You can even whack something like a bloom filter in front of it to remember.
I said all those things too. I said, but don't I think Avalanche was writing shit down. I said, don't anything.
Don't
There's
write it down.
a bunch of ways we can make this smarter. But
get it right first.
Yeah, let's get it right first, and if it's, and I want to see the whole thing. Sort of, I think what I'm proposing all makes sense, and obviously in a week's time we're just all gonna laugh at the stupid idea. But I think it, for now, I still think it does. So at this stage, I'm more about like picking on the idea and the in quotes architecture itself, than really coming up with a smart right behind queue. That we can do, and we got all the time. Place. Yeah, I thought that was also the bloom filter was the first thing that came to my mind. Anyways, so yeah, that's already it then for me. That I just wanted to share this. I think it's a good idea. It's going to make the life of our users much easier. You can't really shoot yourself in the foot anymore. And if you do, at least your application doesn't start corrupting or lying or anything. Worst case is, if we really have brain dead implementation all the way through, is that you will start seeing crappy performance again. But again, there are a bunch of ways of going about this to avoid that. So, yeah. Cool. Then I'm sorry, that's already it.
I'm multitasking.
I can tell.
This is rebating something in Git, so it doesn't require thought.
Cool.
Until proven otherwise.
Yeah, exactly.
If I need to do it, if I fuck up and it requires thought, I'll just have to do it again. No harm done. Sorry,
okay.
It's now 18 plus.
Yeah. We almost matched this time.
Every time. Hey, it's got to 240. What? Actually, somebody probably cursed earlier and we didn't notice.
I got a yeah, most probably. I got another question on this whole GMH stuff. It's not really sensible per se. It's just that I would want to see proliferation of perf measurements tests and things. Talking about the regression thing.
Mm-hmm.
But can we even port all that to clustered and other topologies? It's not sensible because you don't need that kind of, all the pitfalls and things. They all sort of disappear or something. But and what I'm thinking, I guess, is it's probably more in terms of like sizes of things, and because if it seems like for everything that's like just like the stuff that you tested, there are pitfalls, right? So if this all like gets them out of the way, it's good.
Mhm.
But yeah, so what do we just make those tests throwaway tests? Or I think it's stupid. If you write this, I think we should run them. We should record the results and.
Well, yeah, we need though to find a place to run them. Because we could try on CloudBees, but I'm afraid it's going to consume minutes.
No, that I wouldn't do, indeed.
Yeah.
Though, yeah, though even that though.
Yeah, no, it's.
Yeah, but that's a good point.
Well, but
so
you're,
anyways,
talking about JMH. You want to run JMH tests on continuous integration? That's what you're talking about?
Well, it's more about yes, but let me. So this is sacrilegious to say because this is the open source, visible by the public meeting. How important do we think it is that the? So I think it's very important that the pass-fail is the build broken CI system is public, because otherwise it's almost impossible for externals to work on the software. They won't know when they've broken stuff in CI. I don't know how important it is that
the perf testing
that CI perf testing is publicly visible. Not that we would hide it for intentionally or for nefarious reasons, but just that if it is most convenient for us to run it in-house and not expose the results, at least not live.
And CloudBees run on EC2, right?
Yes, I wouldn't trust it anyway.
Yeah, so yeah, indeed.
You need to have dedicated hardware to run that stuff on.
Yeah.
I would avoid virtual machines unless your interest is in performance profiling or in measuring the performance on that specific kind of virtual machine.
What would be really cool is manage a way to automate all that, run all that, and have, I don't know, like a daily or weekly or
Push.
or no email.
Report. Yes.
A digest.
You know, what I was going to say is you could
feel like. So I know I discussed that with some of you, but I still would like to see everything that gets merged to master to be perf measured.
Yep.
Right?
Yes.
Then have all that recorded, and then, yeah, have a daily. I'm fine with the daily, but I understand that some people will find it annoying. We just need, and you just send in a digest like every n days, and
Okay, but my question was more about the tool, because JMH is not to do some performance testing, it's to do some micro benchmarks. Micro benchmarks is when you want to measure what code is faster during implementation. It's like you do some, whatever you do in your get, you want to do what happens when you remove some functions. So you don't run that daily, you run that when you are implementing. That's my micro benchmark, that's one thing. Another thing is performance regression, but it's another.
Yes and no. The problem is that the API layer, right? So what Louis is testing is directly the Ehcache API. It just has so that given a given topology, it's a micro benchmark that comes with all the pitfalls of writing micro benchmark. This is why that's the tool that got used. But what I'm saying, so what do we do? Do we write like micro benchmarks for on-heap only, and then we write other ones for like the other cases?
You don't want to use micro benchmarks for generic purposes. Micro benchmark, what you would do if you want to really, at least for JMH, what you want to do is to test, for instance, the path of a get when there is a hit. To test only that, to measure what happens when you're going to change the internal code. Then you're going to measure what's going to happen when you go through the path of a miss, and then you're going to change your code and measure how you can improve your code. That's the point of a JMH micro benchmark. If you want more than that, then it's another kind of performance testing.
Okay, but I want that.
I don't draw such a specific line, but
no, but even I want that, and I want to know when we make it worse. So I'm confused.
The same argument can be made, Aurelian, that you don't need to run unit tests except when you change the code.
Yes, but
The reason we have unit tests in place is that if people change the code and don't thoroughly test what they're changing, or don't think about, or don't take into account how they might affect the code, that we catch it. Same thing with performance. If I have a micro benchmark that's testing the performance of a get when it hits, and a get when it misses, and a put when it's overwriting, and so on, then if somebody touches a code path and causes a regression, we catch it.
yes, but that's the difference between unit testing and performance testing, because microbenchmark and especially GMH, the goal was to do some investigation, was not to test, it was to do some investigation. So it's a step you do before profiling.
Right. It might be a slight corruption of. It might not be what GMH was designed to do, but it is not a bad thing in of itself. There might be better frameworks for doing that, though. I don't know.
Yeah, I'm not sure, because when you're in the heap-only case, you better make sure you measure this right? Otherwise, what you're going to measure is not what you care about measuring. That's the one reason why I said we probably want to try to use GMH for that. And I understand that for the rest, it's probably not relevant. It doesn't solve those problems, but I don't want to write like every test twice, right? Does that make sense?
Yeah.
And maybe we don't care, because maybe indeed the only thing we keep is is that test or a couple of variation of that, indeed, right? But anyways, we still need to run these and record all this and know.
Yes. My suspicion is that I think that the performance regression stuff, CI stuff, doesn't have to be. It's not as strong a requirement that it be publicly accessible live as it is with sort of functional CI, like is it broken testing.
No, yeah, exactly.
But it is. I think the results should eventually become public. So whether that means an email digest once a month, once a week, or once a day, or
once a month is too much.
Yeah.
Effectively, it's also a way to make sure that somebody looks at them.
Or
it's not the red-green.
Or you have or potentially, I mean, it's not hard to have, like, if it's a web UI that shows it, to once a day crawl it and duplicate it as static content served through the main web server.
Yeah.
Mm-hmm.
And that way you can, everyone can see the CI. It's just you see it slightly time delayed.
Mm-hmm.
So you prefer a summary which gives the result rather than an alert in case that there is some.
The alerts too.
Well, yeah, yes, you can, but let's be honest, right? It's not a stop the world thing. Something goes south. We just need to understand what happened and address it at some point. I don't want to. It's not like a broken build, right? I want whoever made that. I don't care that it's 6 p.m. and he goes into his dinner. He comes back and fixes it. The performance thing, it's important to know and to understand it, and then maybe say, all right, we'll address it, we won't address it, or blah blah blah. But
this is getting down.
Tapping in the dark, I don't like so much.
Yeah, this is getting down into the weeds a little bit about what exactly policy-wise you would do. Personally, I would have both. If there's a significant regression, like a big one, like someone halves performance or something like that, that should trigger email.
Right. So if it goes down by every merge by 1%, that's fine.
Yes, but if it goes down by 1% every merge, that's fine, because that's the kind of thing that you'll catch after a month or a week and go, shit, hang on, no one commit caused a massive regression, but we've halved the performance over a week.
Right.
One of the reasons you have to do that is because you'll get run-to-run variation, so you can't do email alerts with tight constraints.
You know, Chris, it's like all the stuff. I'm not sure what it was, but remember we had the slew clock, the timestamper, some stuff in Quarks, and then this runs like we got like false negatives like like every week you would get them.
Yeah, and it's annoying.
It's annoying, right? Exactly. So honestly,
particularly as every time, no offense, but every time it failed, a new person in QA that wasn't aware of it would notice it and then ask you what, and he's like, because it's a performance test and it's not guaranteed to pass. And eventually everyone in QA knew that, and then everyone just started ignoring it, which is almost worse. Because at that point, it could have regressed, and no one would have noticed. Because they all
this is why I think like a graph, like graphing things,
is ideal.
A picture is worth many red
emails.
Yeah.
Yep.
Or blobs.
But it helps if the graph is pushed to you once a week,
Yeah.
so that you don't forget to go
Exactly.
look it up.
Yeah. To everyone, you get it. Here's the thing. Shouldn't be too hard. Cool, I guess.
Cool.
Well, looking
Yep.
forward to see what costs. I got my ideas, but I'm most probably wrong. So.
Well, we'll see.
Probably.
So you have homework, Louis, right? So who's the manager again? We need to figure out. No, seriously.
Not your manager.
We shouldn't let that drop to like.
No, so what I'll definitely do is run it on a bigger machine with way more threads. See what it gives.
Mm-hmm. And just that we have a plan on moving forward. So I realized Thursday. I realized next week we're all in the office in San Francisco. So I don't want to like restart looking into this in 10 days from now.
I have a question if we're all done with other stuff.
Yep.
Do we want to talk briefly now about what we're going to do, what's happening next week? I don't know if we're having a meeting or if we're doing anything special, or I can't remember. We talked in other meetings about doing something special next week, or whether we would do it or whether we wouldn't do it. And I can't remember who was in those meetings.
We discussed it, you and me.
That's right. Maybe it was my one-on-one. I guess so. So next week, for those that ever watch or listen to this, is an engineering week for Terracotta, and all the engineers will be in the same physical location. Well, that's not true. All of the engineers will be in two distinct physical locations in two different parts of the world. But more of the engineers will be in the same physical location. In particular, the 4 people in this room will all be in the same place. Well, this virtual room will all be in the same physical room. And so there was discussion about whether there was anything special we wanted to cover or what. But we don't have to discuss it now.
My take is, honestly, at this point, I don't know.
My take is I don't have a take.
Yeah, no, it's I don't want to make a decision a week in advance. Come on, we've been canceling this meeting 10 minutes before it happens, so
yeah,
we probably can do better, and we should. But it's not like so I'd rather have, be able to postpone the decision and do something if it makes sense.
We'll decide it over beer next week. We can decide over beer next week.
Yeah, exactly. And also because I believe
if you want to be really sad and depressing, we could offer to do it in person somewhere and invite people. Since we're in the heart of Techland. But that might just be too depressing when no one turns up.
And first of all, and second, it suddenly puts way more pressure on getting good quality audio. Because if
we're all in a physical location, then the audio.
Okay, not live. Just okay.
I meant not live. I meant we could do a meetup.
Okay. Yeah.
Where they can badger us in person.
Too bad then. Beta's not out.
Yeah. Oh well.
Okay. Yep.
Sorry for that random diversion.
All right, good. Awesome. It's a wrap, I guess. We'll see you about next week.